and almost all 3 months have been over. I took the class in the month of April. Yeah. What I was talking was this is the source. Okay, and we have this feeder impedance. Okay, and we have a transformer over here, and then the load is there. Okay, and then the load is there this way. Okay, this load demands the real power as well as the reactive power also. Okay, but especially when this reactive power, as you know that this is not an useful power, but it's still drawing, it is still going to send by this particular source, by source, that is PS and JQL, it is going to supply. At this moment, what happened was there is if the reactive power is not at all useful power on this particular transformer, because of this feeder impedance, because of the power which is flowing from the source is PS as well as the QS, there is a dip over here in this particular voltage. I just mentioned as the VT. Because of that, what they has to try to do was the distribution transformer, they need to change the tap settings over here also on this particular transformers. If the tap setting has reached to the maximum extent, okay, it has reached to the maximum extent, then the loads which in that case, the distribution transformer may not able to provide the transformer, may not be able to provide the voltage. And also what happened was the voltage is going to dip, as we know that the more the reactive power is going to, we will be feeling that there is a voltage dip is there. In that case, they will going to change the tap changing transformer. They're going to change the tap setting on the transformer. See, in that case, what happened was the QS is not at all required. The QL is not at all required also. In that case, what happened was the transformer is get overloaded, Why? Because it is overloaded is the more the current which is going to flow, and the current which is going to flow with in the load transformer is not at all a useful power. Okay, not at all an useful power. Okay, one thing is the voltage is going to dip down. Then in that case, the current which is there, it is going to increase. Why there is an increase in the current is because of there are the loads which have been there in the connected to this particular distribution transformer, or some of the loads are a constant power loads. They won't see what the voltage it is. They will try to maintain the power is constant. In that case, you have a current which is going to increase in order to make about a constant power also. Especially the current is going to increase. In that case, the distribution transformer is overloaded. That is a very serious problem with respect to the electric utilities concerns. Okay, this is one of the problem I'm just mentioning about it. Okay, one of the problem. Yeah, one of the problem with respect to the electric utilities. Even like the electric utilities, there are other problems which are going to experience is if when all the loads is going to shut down. Okay, that means that then all the loads is going to shut down. Then what happened was the distribution transformer is going to change the tap setting, because if you remove all the loads which are being connected to the distribution transformer, okay, a distribution transformer, in that case the voltage is going to shoot out. Okay, that the distribution transformer is going to experience this particular voltage. In that case, they try to remove it also, but it all have in the the tap settings is also changed in automatically also. Okay, it is not a manual kind of a tap setting changes, but still sometimes it experiences the over voltage. Okay, it experiences the old voltage because of the loads also. Apart from this, there are other voltage issues or other kind of a power quality issues that causes a huge damage to the electric utilities also. Okay, huge damage to the electric utilities. So because of that, both the electric utilities as well as the end users are concerned more about the quality of the electric power. Okay, the electric power. Yeah, there are four major reasons. There are four major reasons for the increased concerns. Increased concern in power quality. Okay, especially the microprocessor based controllers and DSP based controllers are more sensitive to the power quality variations than was equipment used in the past. Okay, earlier there was analog controllers which is being used. Nowadays, like uh, the digital based kind of controllers have been coming up, uh, and power electron device is more sensitive to the power quality variations than was the equipment used in the past. The simple thing is almost all the controllers, even the power electronic devices, which are going to uh, take a reference with respect to the zero crossing of the voltage. Zero crossing in the sense we have a sinusoidal signal. The zero crossing in the sense the waveform, when you see the voltage waveform, you have a sinusoidal, especially the zero crossing is over this for one cycle, and this is also for a next cycle, this is a zero crossing. The zero crossing is very much concerned with respect to the power electronic devices, because whenever you want to trigger any kind of a switch, we take this as a reference, and then we extend our control algorithm. Maybe we can try to turn on this switch at this particular time with reference to this. I'm just giving an example over here. Even the microprocessor based kind of a controller, we will be having the clock frequency. All these clock frequencies are referred to the very much referred to the zero crossing of your an input signal, maybe sinusoidal signal. Okay, especially I'm talking about with the AC network. In that case, uh, it will be a very serious problem, and it is a more sensitive, especially with respect to the zero crossing of the your sinusoidal input voltage. Okay. Yeah. Next point is the increasing emphasis on overall power system efficiency has resulted in continued growth in the application of the devices such as high efficiency, adjustable speed drives, and shunt capacitors power factor correction to reduce losses. This is resulting in increasing harmonic levels on power systems and has many people concerned about the future impact on system capabilities. Especially when you are going for an adjustable speed motor drives, okay, that is a adjustable speed motor drives. Anyway, we will be going to use any kind of a power electronic devices. Maybe if you take about a DC motor drive, we'll be going to have a control rectifiers also. Okay, and then if we are going for an induction motor, we are going to use as an inverter. These kind of the inverters, it is obviously when we are switching on and off. Okay, switching on and off. That means that the impedance on the particular load, on the source, especially when you're talking about this adjustable speed motor drives. I'll just give a small example over here. Okay, this particular source is having a diode and then a rectifier and then the resistance over here. You have a sinusoidal AC signal. One thing is the impedance which is there. If you see at this particular point, Z of t, okay, at this particular point is going to change. Okay, one thing is when you have a positive signal, it offers the low impedance. when have a negative supply, this offer the very high impedance. Okay, the impedance is changing with respect to the a time, with respect to the a time. Okay, it is not with respect to any kind of a power electronic devices. It is referred to any other kind of a, a load also. In that case, what happened was there is a non-linearity or there will be harmonics over there in the current. Okay, that's what I was just mentioning over here. When you have adjustable speed motor drives, will be the harmonic current and will it result to the overall power system efficiency. Overall power system efficiency. Okay, this is one of the serious problem with respect to the adjustable speed drives. In that case, uh, also it is also one of the serious problem with respect to the then utilities also. Okay, and then we have seen like the shunt capacitor for power factor correction. As I was explaining about the reactive power requirement, it is creating the huge power loss in the system also. That is also one of the serious problem when are allowing the more the reactive power. Okay, it is not like that only the reactive power is creating more the losses also. Even the real power is obviously when the current is flowing, you will be having the resistance loss. But the thing is, the reactive power is not at all an useful power in a system. Okay, not at all useful power. That is producing the more the heat loss also, more the losses. Okay, that is creating, that is be impacting on the overall power system efficiency also. Okay, so the many people are concerned about the future impact on the system capabilities. System capabilities in sense like the power level. Okay, when you are see the power electronics usage in a system is increasing day by day. It's not a, we are not going to limit the usage of the power electronic devices. And obviously all kind of a loads, it requires the reactive power. Right? We can't stop of uh, without the using about the reactive power. Okay, if keep on growing about if keep on this adjustable speed motor drives or the power electronic devices, or nowadays like the growth is I mean, tremendously is going to happen to use about the LED lamping also. Okay, that is also a very, I mean, a serious issue will be there on the overall power system efficiency also. Okay, and then we need to see in order to meet this requirement of the harmonic currents and then the reactive power, we need to increase the overall the system power capability also. Okay, that is affecting the to increase about the system capabilities in the sense like we need to increase the number of lines, we need to increase the number of the generating stations, even though the power is not at all an useful power also. That is also one of the serious concern we need to consider about these issues also. But coming to the third point, the end users have an increased awareness of power quality issues. But in India, the people are not aware about this kind of the power quality issues, especially the commercial consumers. They might be aware of this kind of the power quality issue because commercial industries means they are all going into a manufacturing or any kind of a system manufacturer industry. Basically, if there is any voltage variations or the voltage fluctuations, that is impacting on the voltage fluctuations is that is impacting on the an equipment where they are going to use to manufacture. In that case, it have the very serious effects. So the end users are very concerned about the power quality issues. Even like especially when you go for a centrally, I mean, this one, DRDO, okay, especially the DRDO, they were not rely on the kind of they're not rely on the supply what the power grid is going to supply, or they were or any other uh, utilities also, especially when they are launching any satellite. In that case, they were not going to rely on this particular supply. They are going to use an isolated power supply. Okay, they are not going to consideration into the utilities also, because they are aware of the any kind of the issues that will be impacting a huge loss also. Utility customers are becoming better informed about such issues as interruptions and sags and switching tensions, and are challenging the utilities to improve the quality of the power delivered also. Especially with this awareness, the end users they were asking the utilities to provide the better quality of the power supplies. Okay, not the domestic consumers, especially the industrial users only. They are very well informing the utilities to provide the better quality of supplies. In some of the metropolitan cities, all the private uh, companies are coming out in delivering the power also. In that case, the industrial consumers are been asking, or they are asking the utilities to improve this the quality of the power to be delivered also. Yeah, the many things are now interconnected in a network. See, almost in India, all the grids have connected very well also. Okay, integrated process means that the failure of any equipment has more important consequences. Even you might be hearing that if there is any issue over there, that will be impacting in all the grids also. Why? Because if there is any kind of a fault or any kind of a, a generator failure also. Okay, when you have an interconnected system, then if one of the generator has failure, who is delivering the huge amount of the power. In that case, when you have the interconnected system, that is going to impact with the other generating stations also. Okay, all the see now. I mean, the generators may not come up very fastly to deliver the power to be delivered to meet the load if uh, one of the generator is not if the one of the generator is not going to deliver the power also. It is not very so easy. In that case, it will be a serious problem with respect to the interconnected network also. But in India, they have not gone to the isolated kind of a system also. In some of the European countries where I have listened one of the lecture, they are going to have the isolated systems also because of these kind of the failures, and it is going to impact the huge loss in the economy if the all the overall grid if it fails also. These are the major reasons. Very much we need to concern about uh, the quality of the power. Yeah. What is power quality? I mean, how you define? I just have given an example like with respect to the. Mm, I have not given about it. I was just talking about the voltage to be a quality and then the current to be a quality. In general, there are the different definitions are available in the literature. There are the different definitions are available in the literature. This is one of the basic definition which has been quoted in IEEE also. What they say is, in the load wise or in the customer side, they should not result in a failure or misoperation also. With respect to result, whatever may be the voltage, or whatever may be the current or whatever may be the frequency deviation, that should not result in failure or misoperation of the customer equipment. Okay, this is very much with respect to the customer side, it has been written. Okay, it has been written. Okay, the performance wise, there should not be any loss. Okay, in that case, we can say that the quality of the power is good also. Okay, if any problem occurs, especially in a voltage, if you are if the whatever the load which has been connected with a to the source, if there is any problem in the voltage, in that case also the load whatever it requires, it has to give. Suppose we have a computer, right? Any kind of a fluctuation in the voltage, we expect that the system or the laptop, especially the desktop system, should not go into off state. We expect that to be at an on state, whatever may be the variations in the voltage or even in the frequency deviation also. That was we expected. Okay, that they have defined it as the power quality is good also. Okay, and then with respect to the current also, is there any issues which is going to affect into which is going to uh, affect the load also? Basically, if you take about the reactive power, if you take about a reactive power, what we have seen is there is a voltage fluctuations which is going to have the impact. I will give another example. If not, okay, you have you have studied about the induction arc furnaces, right? Especially the arc furnaces. These are the these are the loads which are very these are the loads. It the power draw or power which is required for the arc furnaces, there is a intermittent load change or the intermittent power change also with respect when you are considering the arc furnaces. See, in this case, you will be experiencing when there is a power variations, huge load variation, huge load power variations by the arc furnaces. What happened was there is a fluctuations in the voltage. There is a fluctuations in the voltage. Why we are getting the voltage fluctuations is because of your load also, because of the current. That's what I want to say. Even like when in the olden days, we have when you don't have the apartments culture, we every individual houses is having an induction motor to pump the water also. Whenever we switch on uh, the motor, what happened was the illumination will be seeing a dip. Okay, will be seeing a whenever see that means that the induction motor during the starting it takes the high magnetizing current. Because of that, there is a when you are allowing the high magnetizing current in the with respect to this high magnetizing current, obviously there is a drop will be there on this, more the drop will be there. Then at this particular VD, you experienced a dip or a sag also, the voltage variations. That is will be affected. I mean that I mean when you are there in the dip in the terminal voltage or the sag, that if the other loads which are being connected at this particular point, if they are sensitive, if they are sensitive, in that case this load may not be this load. Maybe this if you take about load one and this take about this particular load two, this will experiences or this will won't give a satisfactory performance also. It won't be give the satisfactory performance. With respect to the current also, we will be having the failure or the misoperation of the customer equipment also. See, any manufacturer of load equipment may define the power quality as those characteristics of the power supplies that enable the equipment to work properly. These characteristics can be very different for the different criterias. For the very different for the different criteria. Suppose if you are buying any equipment or any kind of what to say, a desktop computer or any mobiles also, they specify the voltage limits and then the frequency and then the current also generally. Okay. This specifies about 230 plus or minus 10, maybe the frequency is 50 plus or minus 0.02. That they specify it. Okay. But these characteristics can be very different for the different criterias, maybe for the different voltage levels also. Okay, is going to change when you are going to have a closed loop systems, especially with respect to the a closed loop kind of a loads which are been there. In that case, these characteristics may be differ also. I mean, why they specifies about is that enable the equipment to work properly. Okay, some of the just a minute. Yeah. See, any kind of an equipment, they specified about the what the quality of the voltage to be expected. What kind of the quality of the voltage they expect it also. Even the frequency also they expect it. See, the power quality is ultimately a consumer driven issues. Okay. And the end user's point of reference takes a precedence. Okay, the end user's point of reference, they take the precedence. There are many misunderstandings regarding the causes of power quality problems. Misunderstandings in the sense like the customers, I mean, especially the utilities says about the power quality issues which is rising because of the customers. The customers will think about the power quality problems which is going to rise because of the utilities also. Okay, these kind of the problems will be, especially between the utilities as well as the customers, there are very much misunderstanding about these cause, I mean the causes of the power quality problems also. Okay, one thing is like I was just mentioning about one of the point here. When you take about the dip or the sag, it is going to occur at this particular terminal. See, this dip or the sag is experiencing because of this particular load. Okay, what this particular load 2 will think about it? The load 2 will think about it is a problem because of the distribution transformer, but it is not. Because of this particular load 1, the induction motor starting is causing this particular sag. Because of this particular dip or the sag, this particular load or the consumer is affecting this sag. Okay, I mean, it is not the problem of the utility, it is the problem of this particular a consumer. I was just given an example because of the issues which is raised in a system. There is a huge misunderstanding is happening with respect to the causes of the power quality issues also. In this regard, the survey is conducted by Georgia Power Company, in which both utility personnel and customers were polled about what causes the power quality problems. Okay, what are the major reasons of these power quality occurrence, power quality issues occurrence? The utilities and customers' perception are often much differ for the different criteria also. Okay, we'll try to see now what are those kind of a causes of the power quality issues with respect to the customer perception as well as the utility perception based on the survey of Georgia Power and Co. Power Company. Okay, see, with respect to the customer perception, we have the problems, issues raised because of the a natural occurrence. Okay, like natural means maybe the rain also will be creating the thunderstorms. With that also we will be having the voltage surges. Even when you have a floods also we will be experiencing the uh, cables are got disconnected and they will short to the ground also. That is also one of the issues also. And then the customer perception, the utility wise, the customer, because of the customers, it is creating around a 12% issues only. Whereas the utility concern, because of the utility, the 17% will be the power quality issues. Okay. Whereas a neighbor, it is creating about 8%. Okay. Apart from the customers and the utilities, the neighbor means maybe when you have an interconnected system, in that case, this neighbor is about 80%. The other issues, which is not respect to the natural problems and the customer and the utility problems, they are experiencing about the three problems. Okay, 3%. This is about the customer perceptions. In the utility perceptions, the natural is the 66 also, whereas the customer is 25%, and in the utility wise 1%, and the neighbor is 8%. Sorry, and the other is of 0%. See, among this, when you see this customer's perception of the power quality problems and the utility perception with respect to the power quality problems, the major is the natural. Okay. The major is the natural phenomena. Like I have given here the lightning phenomena example. There may be a tree fallen over the lines also. Okay. And then the line also got disconnected because of the floods also. Okay. That also creating uh, the serious fault. Much more frequently than the utility perception, think that the utility is at fault. Natural phenomena, customers much more frequently than utility personnel think that the utility is at a fault also. Okay. Even the utility, if it is at a fault, then also you will be seeing it as a uh, the natural fault only. No, I'm mistaken over here. See, 2/3 of the problems over this pie chart, we will be seeing that the more the problems which are been occurring to this, the natural problems only. Okay. This is about the survey where we can see that the causes of the power quality problems also. Yeah. When there is a problem, power problem with a piece of equipment, the end users may quick to complain to the utility of an outage or a glitch that has caused the problem. However, the utility records may indicate no abnormal events on the feed to the customer. A case where the end use equipment was knocked offline 30 times in 9 months, but there are only 5 operations on the utility substation breaker. It must be realized that there are many events resulting in end user problems that never show in the utility statistics. Basically, what happened was um, in the end users, if there is an outage, or there is if the equipment is not performing, it's almost 30 times in a 9 months. But the utility is recording the breakdown or breakdown of the entire system is hardly around 5 times. Okay, this is all going to happen because of a failure in the because of failure in the uh, end user equipment. See, one thing what I mean to say that uh, the end user equipment in suppose in the equipment there is a line has been grounded or line has been shorted with the other lens. Okay, line has been shorted in the with the other lens. What happened was the breaker is going to completely going to off also. Okay, if there is a an in the equipment there is some kind of a fault which is causing the breaker to be uh, to knocked off. In that case, what happened was they sees that the customer side, they sees that it is because of the problem with the some other means also, maybe because of the over voltage in the system also. Okay, but as such, like in the utility side, it is not having any kind of a problem also. Okay, as we have seen, like in my house itself only, if there is any a short circuit in equipment, what I see that there is a suddenly the breaker is going to trip. That is not because of the problem with respect to the utility also. That is the problem with respect to the uh, your equipment inside your equipment also. Sometimes it so happened that the over voltage is going to be there from the utility side also. It is a very rarest case. Generally, the utility side as such, like there are very much mm, the utility, they have the good technology to regulate the voltage very fastly also. Any over voltage issues also. Because of that, uh, the majority of the problems which have been occurring is because of the end user or the customers only. It is not because of the customer, because of the utilities. Okay. See, and I'm giving you one more example, the capacitor switching. What generally the capacitor switching is going to happen is may not, you may not be experiencing also because you never have used this capacitor kind of a switching in our day-to-day life. See, whenever I give an example, just a simple example. Whenever you connect a huge source to already a system which is available also. Okay, already a system which is available also. Suppose if you connect a huge source, something like on this particular to this particular system. Okay, what happened was this system is capable to have or capable or working with respect to this particular voltage or particular to this system itself only. Whenever you are connecting a huge source over here, you are pumping out the huge amount of the power to this particular system. Then obviously, in order to take that power or to drive that power, because most of a system of a distribution system or any kind of a transmission line, what we see was we'll be designing the transmission line with respect to the by considering the inductance and then the capacitance, right? Okay, even in our loads also we'll be having much about the inductance also, especially when you're talking about the loads, it will be of the inductors. Especially when you take about the transmission line or the distribution line, with the distribution line itself is been designed with respect to taking the consideration of the inductance also. Even transmission line, they have gone for a long, medium, and short line. They have designed by considering the inductance or maybe the capacitance also. But when you say about a line design with respect to the inductance and the inductance and the capacitance behavior, you all know about it. what is the basic property of the inductance? It won't allow the sudden changes of the current. Whereas a capacitor, it won't allow the sudden changes of the voltage also. That is causing an over voltage or over current also in a system, because huge amount of the power, when you stay about the lightning phenomena, the lightning phenomena is when you have a thunderous collision, there is a huge amount of the charge dissipation over be there through the lightning. It will be a touching over, or it will be going to contact to the line. Okay, what happened was, if you have any insulators, there is insulation failures also because of the high voltage is going to impacting on this particular uh, the insulators. If you have a surge arrestor, what is happening was the surge arrestor is just an impedance, is providing a low impedance for that particular lightning also. What I mean to say that because of the inductance and because of the capacitance in the line, and it is not allowing the sudden changes of the voltage or the current, because of that we'll experiencing either the over voltage or the over current or the over current. That's what you were saying about it. The transient in the over voltage that disrupt the manufacturing machinery also. It is a very, especially the capacitor switching, which is quite common on the utility system. Okay, capacitors, they are going to, in the utility system, they are having the capacitor bank, they are going to turn on and turn off uh, when when the consumers are not having the capacitor bank also. If you take about the domestic consumers, no domestic, I mean, I've never seen that the domestic consumers are using the capacitor bank to improve the power factor. In that case, the utility itself has to take care of connecting the capacitor banks also. Okay. One thing is, the utility side, they see that they'll try to see that they try to see that to send the only the useful power. They were not going to send a non-useful power. Okay, if they are going to send a non-useful power to the loads, in that case we are underutilizing the source. Okay, we are underutilizing the source. Why? Because we are sending amount of the reactive power, the more the reactive power. Okay, because of that, they are going to use the capacitor switching. When you are connecting the capacitor switching, we are connecting a huge amount of source. Because of that, it causes a transient over voltage. The transient over voltage that disrupts the manufacturing machinery also. This is the one of the cause or the power quality issues which is raised because of the utility also. Because of the utility also. Okay. Yeah. In the next class, we'll try to see that the evaluation procedure and also other uh, power quality definitions also. Okay. If you have any doubts, you can ask me now. So far, what I have discussed is, I didn't discuss much about what you doesn't know it also. Most of the things which you might have heard about in your power systems course, especially the voltage controller you might have studied. Okay, that part have been discussed. This particular capacitor switching also you have studied about in some of the power system courses where it causing about the transient voltages. And then we have seen about the who is the major cause for the power quality issues with respect to the customer perception as well as the utility perceptions. Okay. And then we have seen like what is the power quality also. We are not gone to the depth to the how you define the power quality. What we have seen is we have seen just is uh, with respect to the equipment failure or the misoperation, there should not any kind of an issues are related to the voltage or the current or frequency deviation that should not result to the failure or misoperation of the customer equipment that we have seen about. And what are the why we need to concern about the power quality issues in the coming future grid also. Okay, with respect to the feature grid only, because that's what we are seen here. Why we need to concern about more with respect to the uh, power quality issues with respect to the end user as well as the utilities also. Okay. If you have any doubts, you can ask me. Okay. You are one of your classmate Ranjit Kumar, as I was mentioned in the beginning of the class. He wants the class to be